guys are just brilliant.
Got this. Okay, so now those are all questions about moles per liter, but as we mentioned, there's different ways to represent them. So when we're thinking about doing it even moles per liter, we can simplify it and say concentration is really the quantity of solute divided by quantity of solvent. So the one that you guys were just doing was moles per liter. That was just the certain units that you used, but it was the quantity of solute over the quantity of solvent, right? So it's still the same thing. So as we kind of work through a couple examples, just keep that overall general equation in mind. So say you were asked to represent it as a percentage of volume to volume. So that volume per volume is saying volume of solute over volume of solvent. So if you were to find it like this, it would be your C of concentration is your volume of solute divided by volume of solvent and times by 100 to give you the percentage, right? So just look at the way that it gives it to you, V over V. So I need V of solute over V of solvent. So for example, a photographic stop bath contains 140 milliliters of pure acetic acid in 500 milliliter bottle of solution. So that's like pure vinegar. Okay. What is the percentage by volume concentration of the acetic acid? So if we take, so C, so this is like our solvent, is our acetic acid, and this is the solute. So we're assuming altogether there's 500 mils of the solution, but only 140 of those mils are specifically acetic acid. So this is, you go 140 milliliters divided by 500 milliliters. You could put it into liters, it doesn't really matter because the units cross out anyways to make a percentage, okay? So times by 100, and your concentration then here will equal 28.0%. And there's no units for that, it's just percent because your units canceled out.
Isn't the
Question?
solvent and the solute switched around? Like, is the acetic acid the solute?
Oh, when I wrote it up here. Yeah, thanks. See, I mixed it up. Thank you for pointing that out. Yeah, no, you're right. I did it again.
Yeah.
Oh my gosh. Yes? Right?
Right.
I'm right now. Okay, thanks, guys. Whew. That was special. Okay. You guys could teach this. All right. So now let's say we have percent. The W stands for weight per volume. So say if like with the example with the juice, you weighed out juice crystals and dissolved it in water. So this is percentage weight by volume. Oh, and I don't think that I wrote that in for this one. This percent VV should be, just put it into words, percentage volume by volume. Or we just call it percent volume. So here what we'll do is we'll have our C is equal to the mass of solute divided by the volume of solvent times by 100 to give you a percentage. So again, you're not really concerned about the units, it's more about the percentage. Yeah. Yes? Okay. Okay, so now percent W over W, this is percent weight by weight. So when we have our C, this is equal to a mass of a solute divided by mass of solvent times by 100 will give us a percentage. So an example of that, because it's like, well, you're making a solution, so when would you have masses of both of them? So an example would be like, say, if you're melting liquids together to make an alloy, okay? So this one, a sterling silver ring, has a mass of 12 grams, and it contains 11.1 grams of pure silver. What is the percentage weight by weight concentration of silver in that metal? So C is equal to 11.1 grams divided by 12.0 grams times by 100 is equal to 92.5% silver.